Okay, so quite a few videos I have to make. The first one is going to be, even though we've we've done it in class, went over in class, I still make a video just so that you have it. So let me just make this a little bigger. Okay, and we'll work through it. So combining like terms. Okay, like terms are terms that have same variable and also the same variable raised to the same power. Okay, we're combining things that are the same. All right, so let's hopefully you understand as I go along. So now, number one, 3a plus 4a. You can think of it as 3 apples, all right, plus 4 apples. Notice that this letter A and this letter A are exactly the same thing, so they must be talking about the same item. So you can think of it as apples. 3 apples plus 4 apples equals 7 apples. Or in this case on top, 7a. That's basically what that is. Okay, so 12b plus 6b minus 4b. Let's just use the obvious b for banana maybe. 12 bananas plus 6 bananas minus 4 bananas. And since they're all the same, we're talking about the same fruit here, I can subtract or add one with each other. So 12 bananas plus 6 bananas, this would give me 18 bananas. And minus 4 bananas here, after I add those two, gives me 18 minus 4, gives me 14b. And I gotta pause. All right, so back. So, and that gives you 14b. All right, so think of it as a variable in this case, just for my example here, as abbreviations. So let's go, here we go. Let's go to 3. I'll write it out. 15a squared plus 6a minus 7a squared plus 3a plus 3 minus 4a. So what I asked you in class to do is that maybe you want to move things around so all the like terms are next to each other. Okay, that definitely helps. So I'm going to circle this 15, and notice that a is a to the second power. Okay, so 15a to the second power. Is there any other term, the part of this expression that also has an a to the second power? There is, and that's right here. All right, so those two I use that, and then I'll change colors. So if you have a highlighter or something, and then for this, I'm gonna look at 6a. So anything that has an a, this one does, and then I'll try to make this like a little rectangle. And I'm going to put a rectangle around any other term that also has a 3a. So notice that I'm putting a rectangle around the 3a, but also including the operation or that plus sign that comes right before it. Okay, so every time you circle or put a square around the term, make sure you include that operation right before it. And then there's one more here that has an a, so I'm going to put a rectangle over that as well and include that minus sign. And lastly, I have a number 3 with no variables. Okay, so and that's just an old-fashioned number. So let's just use a triangle to make it a little bit more different. Now I would like you to move things around. So let's start with the 15a. So anything that's a, I'm going to put together. So this, and I'll move this guy next to that. So I'm including that subtraction sign, minus 7a to the second power. And then we'll do the a's. So let me move that 6a over here. That's going to be our third piece. So it's plus 6a. And I'm going to take this one, put it over here. So that gives me plus 3a. And then the guy in last is not going to be last anymore. He's going to be here. And that's minus 4a. And then finally, I'll bring this 3 all the way to the back. Let me just try to change colors. And that's a plus 3. All right, so now that all my terms, all my parts of this expression, all the like ones, the ones that are similar to each other, next to each other, I can add or subtract them. So I can add or subtract these two together, 15a minus 7a. So if I had a bunch of a squares, 15 of them to be precise, and I took 7 of them away, I would have 8 a squares left over. Let's do this group now. Well, 6a, 6 apples, plus 3 apples is 9 apples. And if I took 4 away, I would have 5 apples left, and that would be plus 5 apples left over. And then obviously that plus 3 here is doing nothing with no 1 because there are no other numbers for it to be added or subtracted to. And we're just going to write plus 3. So this whole big expression that we started with simplifies to this. They actually are equivalent. They have the same meaning. Okay, only that this is a simplified or the shorter version of that long one we started with. So that's the idea. Okay, it's a lot of work, yes, but you need to in order to simplify this correctly. All right. So I'll do a few more. So you get the idea. Let's do 4. So it's 9x to the third power plus 7x to the second power. The power, the exponent, does not apply to the coefficient, to the number. It applies to the letter. Okay. Plus x minus 4x to the third power. So we have a bunch of x's. They're not all the same. Some are x's to the third power. Some are x's to the second power. Okay, so let's do that thing I was telling you about. Let's group them together. So 9, this is an x to the third power. I'm going to put a circle around that. Is there anything else that has an x to the third power? There's one, the last term. And notice that I'm including that subtraction sign. So these two will eventually be side to side. And you know what? I'll do that right now. 9x cubed. And I'm going to bring that guy all the way to the front, and I'm going to write minus 4x cubed. Change colors. Let's look for everything that has an x to the second power. So this guy has an x to the second power with a plus sign. This one also has an x to the second power with a minus sign. So let's write these here. So I'm going to write plus 7x to the second power minus 4x to the second power. Okay, so they're together. And we have one more. And the last one is use green. I'm not gonna, and that's gonna go all the way at the end, and that's just an x. And there's no, nobody else. Nobody else is like that one. So now I can combine things. These two I can subtract because they're the same. 9x cubed minus 4x cubed is 5. Subtract the coefficients. 9 minus 4 is 5, and I keep the variable the same. Now I'm gonna do this too. 7x squared minus 4x squared. Well, 7 minus 4 is 3. So plus 3. 3 of what? Of the x to the second power. And then lastly, I will just add plus x because that's not doing anything with anyone. Okay. Let me see if I can do something that's a little bit different. Let me do a long one. Let's try 9. N plus 5m squared plus 11 minus n plus 7m squared minus 8. So this has a few different things. Alright, so let's start. N's. Let's look for things that are n's, the letter n. This one, there is one here. By the way, this is n. You only see n, you don't see any numbers. So you have the choice of actually leaving as it is and just understand that there's one single n, or if you would like, you can put a coefficient there of 1. It's hidden, okay, it's invisible, but if you can always, if you're not comfortable with just leaving the letter there, you can just write the number 1. And likewise over here, notice that there's an n here and no coefficient, no number. I'm going to put the number 1 there. Okay, so 1n. Is there anything there's an n? Well, there's something else that's an n here. I'm going to write these two together. 1n. Actually, I'm not. I'd rather you get used to the fact that you don't need to write the 1n. So n, and then I'm going to write this guy, bring this guy over to here, and that is minus n. Change colors. Let's look for anything that has m to the second power. And there's something here. Is there anything else? Yes, there is, right here. So let's put these two blues next to each other. So let me bring that here, plus 5m squared. Then this one right next, plus 7m squared. And then lastly, numbers, just old-fashioned numbers. There's a plus 11 here and a minus 8. These two can be added or subtracted to each other because they're just alike, because they're just numbers, constants. Plus 11, and then the minus 8. So there you go. You got the three different things, the n's, the m to the second power, and just old-fashioned numbers. N minus n is just 0. I'm not even going to write that. 0 plus, now we have 5m plus 7m. 5 plus 7 is 12. M to the second power. And then this green here is 11 minus 8, so plus 11 minus 8 gives me 3. Final answer, 0 plus 12m second power plus 3, or it's simply 12m squared plus 3. Do we really need to write that 0? No, we don't. Okay, so I'm not going to really do everything else, but that's the idea. Okay, so if you have a question, you can always let me know. I will go over these two. So the last four actually. Perimeter. Perimeter is the distance around the shape. So the distance around this particular rectangle would be this side plus this side plus this side and plus this side. And the rectangle, opposite sides are equal. So if this is 3x, we know that this is 3x as well. And if the top is 6x plus 5, guess what? The bottom is 6x plus 5. So perimeter of a rectangle, to find the perimeter, we add all the sides up together. So let's add them up. You get 6x plus 5, which you're going to add to the bottom, another 6x plus 5, plus this 3x, and finally this 3x that's on the other side. We can leave it like this, but we're going to obviously combine the ones that we can. So let's look for something. Let's circle everything that's an x. 6x, well, this is also in the x, and this is also an x, and this is also an x. So those four are of the same type, and we can combine them. So let me just put them together. So 6x, I'll bring this guy over here, plus 6x, and then the last two at the end, plus 3x, and plus 3x. And then we have two terms, plus 5, and plus 5, these are numbers. With no variables, constants, so I'm going to put them at the end, but next to each other, because we can combine them. So let's group all our x's together. Well, 6x plus 6x is 12x, plus 3 is 15, plus another 3 is 18, so a bunch of x's. I have 18x in total. And 5 plus 5 is simply 10. So the perimeter of this particular rectangle is this. That side plus that side plus that side plus this side equals 18x plus 10. So this one is a hexagon. So this particular is an equilateral hexagon. All the sides are the same. If in a hexagon, So if this is 4x, guess what? This side is also 4x, and this side is also 4x. This side is also 4x, and that side is also 4x, and that last side is also 4x. So all the sides measure the same thing. Okay, to find the perimeter, again, is, this side plus this side plus this side plus this side plus this. So you got two ways of doing it. You can realize, well, let me do this a long way. 4x plus 4x plus 4x. 1, 2, 3, 4, 5, and the 6th side. Can I add them together? Yes, I can, because they're all of the x. They're all the same. Okay, so 4x plus 4x plus 4x plus 4x equals 24x. Alright, so, or you could have done, you notice that there's 6 sides and they're all the same, or just simply multiply 6 times 4x, and 6 times 4x is 24x. Okay. 24 and 25 might have been a little bit different. Okay, 24 and 25. So 24 says find the perimeter again of a rectangle, but the clues that they're given you had to interpret. The perimeter of a rectangle was a length, so this is, remember, this is length and this is width. Okay. So what do we know about the length is 5 inches longer than its width. Do we know what the width is? No, so we're going to leave it as W. Okay, we're going to use W to represent whatever value it is. But we know that the length is 5 inches longer. So whatever the width is, the length is going to be 5 inches longer. So 5 plus W would give us the length. So let's say the length was 2. All right, let me put it over there. If the length was 2, what do you think the width, if the width was 2, if this is 2, how much would this be? Well, it'd be 5 plus whatever W is, so this would be 7. Get another rectangle, so and pretend the width was 25. the length over here would be whatever the width is, 25 plus what? Plus 5, which gives us 30. So the length is always 5 more than whatever the width was. So in this case, since we didn't know what the width was, that's why we represent the length of this rectangle as 5 plus w. Are we done? No. So based on that, we'll take this L out. So that's w, this is w, and I also know that this on top is 5 plus w. So we're going to add all those two to find the perimeter. Now we're going to do w plus w, and plus the two lengths, 5 plus w, and another 5 plus w. And we can add things that are the same. I know that this w, and this w, and this w, and this w are of the same kind. So one w plus another w is 2, plus another one is 3, plus another one is 4. That's 4 w's. Plus, and I'm going to add these two 5's, right? 5 and 5 gives us 10. Final answer, 4w plus 10. $25. Same idea. Find the preferred expression for the perimeter of a rectangle with a length that is 4 centimeters. So the length here is 4 centimeters more. More means plus than what? Than 3 times the width. And that's how you would represent that. So the length is 4 plus 3 times the width. And the width is just the width. On top, I'm going to write 4 plus 3 times the width because top and bottom are the same measurement. And then obviously if this is w, this is also w. I'm going to do the same thing here, perimeter. I'm going to add everything. 4 plus 3w plus another 4 plus 3w plus w plus w. Okay, 1, 2, 3, 4. 4 sides. Let's add these. This time I'm going to add the numbers first. Well, there's a number here, and there's another number with no variables. I can add these two. 4 plus 4, right? And then there's 3w. I'm going to bring that over here. Bring this guy over here. And the two w's at the end. So all my w's are next to each other, and all my just constants or my numbers are next to each other. So these two can be added. 4 plus 4 is simply 8. Let me sum up all the w's. 3, 6, 7, 8. So I get 8w. And that would be the perimeter, the distance around this particular rectangle. Over here, you scroll down, this is sort of a maze. I'm just going to start you off here. Alright, so you're supposed to start here. And in this particular square, you add the like terms. So what can we add? We can add the y's together, but not the x. So 2y and that 3y is 5y plus x. So the sum here, or just the simplified expression would be 5y plus x. Look at the arrows. Look for something that says 5y plus x. Well, definitely not this one. X plus 5y, which is the same thing. So, because it's the correct answer, it tells you to go this way. Now, you're at this square. We have 2a plus 2a plus b. Add the like terms, or the terms that are similar. I can add the 2a plus the 2a, but not the b. So I can add these two. And 2a is 4a. 4a plus b is a simplified. Is there anything that says 4a plus b? Well, let's see. Do I go this way? Yeah, we go up. Okay. Once you reach the next one, you add it and see which arrow you can use to take you to the next box. Okay, which of these two arrows will be the correct one, going either left or down. I'll just do one more. So 3x plus y plus 2y. Well, you can add the x's together. You get 4x, and you add the y's together. You get 3y. So it would be 4x plus 3y, which in this case is this. So from here, the arrow tells you to go this way, and so forth until you reach the end. Okay. Any questions? Use the contact form, please, on the front page, the home page of the website. Okay, and just write me, and then I'll definitely reply. What am I supposed to do? I'm supposed to stop.